hardware vendors. So any requirements, I would be here to collect them. Also on the call, we've got Martin Bohm, one of our unified communication consultants here at risual. We've got Gordon Collins, who's the pre-sales at KEMP. And we've also got Maurice Mullin, who's the product marketing manager at KEMP.
Cool. Just so everyone's aware, we started the recording now of the session for today, so it will be available at a later date.
So if there's any questions at the end of the webcast, please don't hesitate to ask. Submit using the instant messaging or email into marketing@risual.com. Your microphone will be muted for the webcast, just so we can get a quality recording. So that I'm just going to start off just talking a little bit more about risual and just giving you a little bit more background. So risual is split into five key different areas. Consultancy is broke down into business and technical consulting. So business consulting covers strategic consulting, engagement management, and architecture, whereas the technical side is split into 4 different teams, which will cover business productivity, which would be SharePoint, UC messaging, which would be Lync, Exchange, and Office 365. Cloud infrastructure would be Azure, System Center, AD, and security. And our application development team will be covering CRM and customized applications and coding. In terms of managed services, with risual, risual can maintain a fully managed solution for Lync, for instance. So it would be one strategic partner to offer the full service using proactive monitoring and reactive monitoring. So proactive monitoring falls under SCOM alerting. So our support guys will do that. And reactive monitoring would be only reacting when there is a problem. And we can also do that on-premise, hosted, or in the cloud. I'm just going to hand over to KEMP just to do a little bit of a company overview for you. So, guys, do you want to take over for that?
Hello, Maurice McMullen here from KEMP. Thank you all for joining. Just to give you a background on KEMP. KEMP are a global organization headquartered in the US, but we're a 24/7 operation in terms of support. We are based here in Limerick in Ireland. We also have operations in New York, on the West Coast, and also in Singapore. We deliver load balancers across a number of different platforms. We've got virtual appliances that sit either on-premise or in the cloud. We've got our own gold box appliances, traditional appliances, and also we have bare metal, where essentially if you bring a piece of Dell equipment or a Fujitsu, whatever, we can essentially take over that there as a platform. We scale in terms of performance right up to 10 gigabits per second on our hardware appliances, and we're very, very focused on the Microsoft workloads. And in the context of what we're doing today, we're certified by Microsoft for Lync both 2010 and 2013, as well as the other Microsoft workloads such as Exchange and SharePoint. And we have out-of-the-box templates there that allow you to get up and running pretty quickly in terms of application delivery there. The only other thing I'd want to mention, actually, just a bit of news from ourselves. Yesterday we released a free version of our load balancer, a virtual load balancer, limited in performance, obviously. We still have to make a living, to 20 megabits per second, but that would allow people to deploy a full-blown load balancer in test development environments as well. So that's the overview of KEMP, and my colleague Gordon Collins is here with me, and later on he'll be going through some of the more technical parts. Okay, thanks.
Thanks, Maurice. So I'm now going to hand over to Martin Bone, who will take you through a few of our slides from a visual perspective. So, Martin.
Cool, thanks, Callum. For you guys who do know me, my name's Martin Bone. So I'm a UC consultant specialising in Lync, in Microsoft Lync. So today we'll just go over some architectures of Lync 2013. We will start with, so in terms of Lync and a Lync deployment, there's two main editions of Lync and deployment architectures. The first one is Lync Standard Edition. So if you took a Lync front-end server Standard Edition, this is intended for smaller organizations. There is kind of a user limit that Microsoft state on the recommended hardware that is around 5,000 users. So there is a consideration there when looking at users and the amount of users that would be using Lync. Although with Standard Edition, you still do get all the Lync functionality there. If you chose Standard Edition over Enterprise Edition, you still get all the functionality of Lync, including instant messaging, presence, conferencing, enterprise voice, archiving, monitoring, persistent chat. So you get all that full Lync functionality with Standard Edition. So one difference with Standard Edition is the back-end databases for the front-end server are co-located using SQL Express. So there isn't a need for a separate SQL server, although if you did choose to deploy the archiving and monitoring role, you still do need and require a full-blown SQL server. So with Lync 2013, it's SQL Server 2008 R2 and above. We would recommend the latest and greatest at the moment. So the support for SQL is up to SQL 2012. So you can, with Standard Edition, have co-located roles, and then you can also have standalone roles. So standalone roles can include the edge server. So that role is there for providing remote access, federation, external conferencing, access for audio, video for mobile devices. If there's a requirement for a standalone mediation server, that can be added as well. One important consideration with Standard Edition is high availability. So with Standard Edition, you cannot provide any high availability. And that's purely around that you can only have one server in a pool. If there was an outage, that would be service affecting. Lync 2013 with Standard Edition, they have brought in disaster recovery. So you can deploy a second Standard Edition server and have pool failover. There is some manual intervention required, but you don't get any high availability. And that can include if you're doing patching, that there would be a service outage. So there is some important considerations with Standard Edition, mainly looking at the amount of users who are going to be using the service and if high availability is a requirement. So we'll just have a look at an architecture diagram of Standard Edition. So in this architecture here, we've got a single front-end server deployed on the internal network. We have an Office Web Apps server that's providing PowerPoint functionality that we are using today. We have a single Lync Edge server in the perimeter network, and we have a reverse proxy server as well. So the reverse proxy server is used for publishing web content out to the internet. And also in this deployment, we have got a standalone Lync mediation server connected to a gateway, providing PBX integration. So you can either have direct SIP trunks from the PSTN network into the mediation server, or you can integrate with a PBX. So in this scenario, all based around single servers. So in load balancing requirement wise, there isn't one here at the moment. Traffic only needs to go to one server, and we don't need to distribute that traffic. What you will get more details on later is that a KEMP load balancer is a qualified reverse proxy server with Lync. So you can look at a reverse proxy server based on a KEMP load balancer deployed in the perimeter network there. So that's an example of a Standard Edition deployment, including all the roles and enterprise voice. So if we look at Enterprise Edition, this is aimed at larger organisations and also where high availability is critical, particularly with enterprise voice deployments where Lync becomes a PBX. High availability is critical because telephony is a critical service to the business. You can scale much higher in terms of user capacity. You can go from 5,000 right up to 80,000. One difference here is that you can deploy pools of servers. So the Lync front-end server in Standard Edition is a single server. With Enterprise Edition, we can scale and have more servers in a pool up to 12 with Lync 2013. Again, we get the same functionality as Standard Edition, but we are getting high availability due to having more servers in the pool. One difference is that there is a requirement to have SQL Server. So SQL Server Standard Edition or Enterprise to provide all the databases for Enterprise Edition. If you're looking at high availability with SQL, so not only with Lync, we need to protect against failures of SQL. So SQL mirroring is the recommended solution for high availability in Lync 2013. SQL clustering is supported now. But what is not supported currently is SQL always on. So SQL mirroring is the recommendation. So that includes an SQL principal server, a mirror server, and a witness server. And that's protecting against a database server failure. There'll be automatic failover of the databases to the other SQL server, and that provides that level of high availability at a database level. So that supports high availability, as we spoke about. We'll look at an architecture diagram there. So this is an Enterprise Edition, and here we're using hardware load balancers. So one difference with Enterprise Edition is that we've got a number of servers in the in pools. So here we need to distribute traffic across the servers. So here you can use the hardware load balancers to distribute all the traffic. Or you can, there is a requirement that you have to load balance web traffic. So HTTPS traffic has to be load balanced by a load balancer device. And that's purely around that with web traffic, that the traffic is session based, and that for example, if a mobile device connected to one front-end server, if you look to use DNS load balancing, that session may get distributed to another server, and that session would have to restart again. So there is a requirement to use a hardware load balancer with Enterprise Edition for at least the web traffic. And Microsoft do recommend that DNS load balance is used for all the SIP traffic, but the web traffic is done by a hardware load balancer. So in this deployment there, we've got two hardware load balancers on the internal network, and they're distributing the HTTPS traffic for Lync across the 3 front-end servers, but they're also being used to distribute traffic for Office Web Apps servers. So here you can see for high availability of Office Web Apps, we've got 2 Office Web App servers. High availability for Lync front-end, we've got 3 front-end servers. And with Lync 2013 Enterprise Edition, the recommendation is a minimum of 3 front-end servers. It can be done with 2, but that's not supported or recommended because there is still manual intervention. If we look into the perimeter network in the edge server here, you can see we have 2 Lync edge servers in a pool, and 2 reverse proxy servers as well. And in the perimeter network, we've got 2 sets of load balancers. We have 2 load balancers on the internal side of the perimeter network servers. So we're load balancing the edge pool internal interfaces with hardware load balancers. And on the external interface of the edge servers, we're also load balancing via hardware load balancer. And that's one critical thing that you have to remember is with load balancing of the edge servers, particularly the internal interface and the external interface need to be load balanced in the same method. So with edge servers, they can be load balanced with DNS or hardware load balancers, but the load balancing for both interfaces has to be the same. When looking at high availability of Lync edge pools, whether to use DNS or hardware load balancers, there's a few requirements that would dictate using hardware load balancers, and that is around whether high availability is required for federation with public IM, such as Skype, federation with legacy clients, Office Communication Server 2007, OCS 2007 R2. So if those are requirements, then that does dictate that you should use hardware load balancers for load balancing of edge servers. If not, the recommended method of load balancing for edge servers is to use DNS. And in this scenario as well, we've got the reverse proxy servers. So they can be web application proxy based on Windows Server 2012 R2. So we're using the load balancers there to load balance that solution as well. And the load balancers on the internal network can also load balance other internal Microsoft solutions in terms of Microsoft Exchange, Active Directory Federation services, SharePoint. So you can utilize and deploy KEMP load balancers and use it across the Microsoft stack. So this diagram here is showing it's showing load balancing, but here we're using DNS load balancing for the edge servers, but we've still got a requirement for hardware load balancing of reverse proxy servers in the DMZ. The internal hardware load balancers are the same. And if we look at this solution here, we're using on the internal network, we still have a requirement for hardware load balancers on the internal network. That's load balancing Office Web Apps and the Lync front-end pool. The Lync edge pool is being load balanced by DNS, but in this scenario, we're using the reverse proxy servers as KEMP load balancers, and they are qualified as a reverse proxy server by Microsoft for Microsoft Lync 2013. Okay, so there are some load balancing requirements to remember with Lync 2013, particularly Enterprise Edition, where we have pools of servers. So if that's front end, directors, edge server pools, mediation pools, there needs to be a deployment of a hardware load balancer. So that load balancer device can be a hardware-based solution, a virtual-based solution. That's just dependent on performance, number of users required. In Lync 2013 does also support DNS load balancing. So the two load balancing methods for client to server traffic is based on DNS and hardware load balancing. And when you choose the most suitable solution, whether that's load balancing, there are some key things to remember. And that includes that the internal edge interface, external edge interface must have the same type of load balancing. We can't use DNS load balancing on one interface and a hardware load balancer on the other as well. The HTTP traffic, HTTPS, does require a load balancer. We cannot do that with DNS load balancing based on that session traffic. And if you do choose DNS load balancing for the pool, you still need to implement a hardware load balancer for the HTTP traffic. And that's the key thing to remember is the HTTP traffic really. Is that is session based. It does require a load balancer. And that's everything from me.
Thank you very much for that, Martin. I'm just going to hand over to Gordon now from KEMP, who's going to go over some more slides with you.
So my name is Gordon Collins. I'm pre-sales engineer for KEMP Technologies based in Limerick in Ireland. So as Martin has touched on some of the load balancing stuff, I'll just kind of fill you in as to how KEMP fits in with Microsoft and also with the deployment of Lync. So as Morris alluded to, basically KEMP has been a kind of Microsoft partner for a number of years, and a lot of our business and a lot of our applications we support are Microsoft workloads. So anything from SharePoint to Lync to Exchange, we've got instances in Azure. We can tie in with Office 365 and RDS and stuff like that. So anybody that's working with Microsoft and feels the need that a single server will issue kind of restrictions to their network and the need to branch out and have high availability, KEMP can certainly help and kind of guide you towards the solution that you require. So just the basics of load balancing. I'm sure everyone is pretty much aware of what it intends to do. So a load balancer has a lot of kind of advantages over DNS load balancing. So one of them that Martin touched on would be session-based, and what we classify it as persistence. So basically what that means is that for every client that connects to a load balancer, we have the ability to direct that client to a specific server and keep a session open for a set period of time. So if you're working and you are connected through a DNS load balancer, you have potentially the session could close, you mightn't be finished what you're doing, a user will see an interruption. Whereas with a load balancer, you can set the sessions to time out for a certain time. So if somebody is working on a web app and you want them to be able to get the same real server, same session over an hour, you can set that so that any time that the person connects with the virtual service or the VIP, that they will go back to the same service, and it's a continued session. People don't see any interruption. It's like they're directly onto the same server when in fact they're directed through a load balancer. So again, what the load balancer also does is health checks. So this health checking, while the DNS can check if a system is alive through pings and stuff, a load balancer has the intelligence to check an application. So if you have a particular application, might be down but the server is up, the load balancer can check that. If the application is down, it will direct traffic to a server in that pool that has that application up. And then once the server becomes, that application becomes available again, the load balancer will be checking it every couple of seconds and will add it back to the pool once that is available. So again, it really impacts on user experience. Users don't realize if an application is down, there's no failover between servers noticed. It's just all working in the background for you, and it helps kind of generate this one environment that it looks like it's one server, but it could be multiple servers. So again, you have, when we say load balance, we talk about algorithms, and we call them scheduling methods. So you can identify what way you want the load master or the load balancer to schedule clients onto servers. So there's a number of these. It goes from round robin, which is fairly basic standard, to least connection, which basically reads the statistics, of what is currently on a server, and it will dictate the client goes to the server with the least amount of connections. Or you can have a resource-based, where we have a client, a 10 client that runs on the server and reports metrics back to the load master, such as memory usage, CPU, input-output, and we can send traffic based on the lowest amount, and that's completely configurable by yourself. So some clients might want the memory to be more available. If that's the case, they can configure that through the little program that we have. So that kind of gives, even though there might be 100 users on one server and 10 on another, like the 10 on the other could be doing something that's hammering the resources of the server, while the 100 users might be just logged onto a web page. So in that case, it might be still better to send the traffic to the server with the 100 users. So these are all things that KEMP can do, and you get to see if you start to work with KEMP and kind of download and install trials and stuff like that. It's fairly kind of easy. Another thing with the KEMP Loadmaster is it's a one free field. So from the free trial or the free Loadmaster that Maurice discussed, if you download and work with that, it's the very same field for that right up to the top end of our products. The only difference being will be throughput and SSL TPS. So again, I think Martin touched on a lot of this. Basically, for Microsoft have certain recommendations for load balancing Lync. So what should you load balance? You don't need to load balance server-to-server traffic. The servers are totally aware of the other servers in the topology. You need to load balance client-to-server traffic. So again, the SIP traffic, which is the initiation traffic, that's DNS load balance, right? DNS load balance does not work for web traffic. This is basically one of the main reasons is the session awareness and the ability to maintain consistent sessions for clients. And again, like also there's port translation is required for external web service traffic, because it comes in on one port and needs to go to a particular port on the servers. Load balancers have the ability to do that for you. So this diagram just kind of highlights it's just a visual diagram really, just highlights exactly where we can add value to a Lync environment. So enterprise edition server, edge server, mediation server, and the director. This topology just kind of shows where the load balancer would sit. It's similar to Martin's diagrams. You can see there we've got basically two load balancers in this diagram. One is for the internal network, which would take care of the front end pools, the Office web app server, and then we've got a load balancer in the DMZ, and in this instance it would look at the edge, the Lync edge pool, and also if there was a reverse proxy, and also the KEMP can also act as the reverse proxy and is certainly certified by Microsoft to do this. So Microsoft load balancing the front end and director pools. So these are the pools on the internal network, and Microsoft recommended method is you use DNS load balancing for SIP traffic. While it's DNS, we can still handle that traffic through a hardware load balancer if you have one in play. You configure a web service for the overall FQDN for internal web services. And again, we can load balance specific TCP ports, such as 80, 80, 80, 443, 4443. If you have director deployed, we need to add 444 for this. Load balancing, again, it comes to persistence, the session-based. There's a number of ways where we can help you here. You can have a session based on the source IP. This is fine if you have a small environment, or if it's completely unique IP addresses in the same internal network. But if you have people logging in from behind firewalls and stuff, or other NAT devices, again, there's the problem that people will show up as a single IP, and it might result in uneven distribution because everybody on that same IP would go back to the same server. What we would recommend is you use server cookie for persistence. Now, there's no negative impact here for server cookie. Just a couple of conditions will be like obviously it mustn't expire, must be named a specific name to work with KEMP, and the name is on the screen there. So what we do is we'd health check on TCP port 5061. This would be, it's just a standard protocol issued by Microsoft. So the load balancer only configuration on this is DNSR not used for SIP. So these are the ports listed, and there's a URL added as well to this presentation for more information that Microsoft has given on the specific ports required for setting up Lync load balancing. Again, load balancing and mediation pools, it's really only, DNS load balancing is sufficient. And again, if using the load balancer instead of the DNS, the load balancing TCP connection on 5070 only. So again, when you use load balancing the edge pools using DNS, there's certain scenarios where there won't be any failover, and Martin kind of touched on them there. If you want to work with Skype or the older versions of Office, then such as Lync 2010, there won't be that kind of backward compatibility for when you're using DNS load balancing. Again, you need to be able to transfer calls and stuff out of there into different areas. So we can, when you're using the load balancer for the edge pools, so there's obviously there's different interfaces that need to be load balanced. There's the external and internal interfaces for the edge pools, and as again Martin touched on, you need to use the same method of load balancing for all. So the different interfaces that need to be external ones will be the Access Edge interface, the web conferencing interface, the AV Edge interface, and then what you need to do is you need to set up the load balancer access lib as the default gateway of all the edge interfaces. So again, you can't have a kind of situation where you decide to balance the external on one kind of load balancer and the others on DNS. It's just a requirement from Microsoft, and it just doesn't work without them being balanced by the same hardware load balancer or DNS load balancer. So again, this slide just gives kind of ideas of what the internal interface is. So it's going to be your access SIP, your authentication SIP, your media transfer. And these are the ports that you'd need to load balance, because these are the ports that Microsoft have set up on the servers for the services to be running. So again, in the DMZ, you're going to have a reverse proxy. So what is reverse proxy? If you haven't come across this, I'm sure you have. It's a device deployed between clients and servers, usually in the DMZ, that interacts with servers on behalf of the client. So it's very commonly used for a number of applications, specifically Microsoft Lync, Exchange, and stuff like that. So it's for availability and scalability, and it terminates TCP traffic. What it can do in one layer is it can protect the real server from getting hit from external clients, where the VIP is taking all the traffic and providing access to the network through a single point. And what the KEMP does is it's fully qualified to provide full reverse proxies. And what this does is it's using advanced layer 7 features such as SSL offloading. So that's where we would have a certificate on the load master. You would decrypt the traffic that comes in using this cert and pass it on, reading into the traffic, deciding where it goes for traffic management. So like you have the ability to send this traffic through to the server on port 80 or 443, depending on how you want to set it up. So this is just a feature list of what you're required to do to set it up. So basically it translates server ports from 80 into 8080 and 443 to 4443. No persistence is required. You need to have a 20-minute TCP session timeout and 1800 seconds TCP idle timeout. That just means that the 1800 seconds is a client can be away from their machine for 5 minutes, and then the 20-minute TCP speaks for itself. So that means that there's no activity between the client and the load master for 20 minutes. They will close the session. Again, 5061 is the health check here. And also you can create your own blank page instead of 5061 to ensure IIS is working. So what, like the load master, what KEMP does really well is it health check specific pages, and developing health check pages enables you to understand if your application is available, not just the server or the role. You'll often find that the port will be available, but the service behind that port could be down for some reason. So the Office web app servers, it's TCP traffic. So this is where the HLB is recommended by Microsoft. So again, you're able to load balance on TCP 443, enable and re-encrypt SSL. So you can use your either source IP for persistence, and then you can use other methods if NAT is there. So like using the server cookie is probably the preferred method from KEMP. And what we would do as a health check, we'd perform a get on a particular health check page. So just DNS or external load balancing, there's pros and cons to both. So what you can see is the load balancer pros are app awareness, which is making sure that the application is actually available as opposed to the server. Easy to take partially over working server offline, so you can work on a server as long as you leave a particular application available for the clients and support the clients. The cons, like there's extra steps for server training and additional setup required, but there's also cons, but what we call a myth. It says it adds to the deployment. We don't believe so. KEMP provides plenty of templates on Microsoft Lync 2013, 2010 to enable you to get the best practices with a touch of a button. And it adds latency, which is a complete myth. We've been tested and certified by Microsoft in 2010 and 2013. And then again, overcomplicates troubleshooting. We don't believe so. We've got a team of engineers locally here that have vast experience in setting up and deploying Lync and following on troubleshooting any issues for clients. And then just due to DNS, there is some pros, which is less complex. Obviously, it's less complexity and minimal LB expertise required. But again, DNS load balancing cannot do the complete Lync load balancing setup. And then this is just a page for best practices. And KEMP website is full of guides and documents on how to deploy KEMP and the kind of the things to watch out for when using a load balancer with Lync and Microsoft Exchange and stuff like that. So it's a good kind of reference point to go to. So there's some resources here. We just wanted to point you towards some KEMP templates as we've discussed, deployment guides, and then the Microsoft solution. And there's a lot of how-to videos using KEMP. So it worth people's while to maybe get a look at them, that information. And I believe that is.
Thank you very much for that, Gordon. Thank you. And guys, you'll now be unmuted, so feel free to ask any questions. If you're feeling too shy, just want to drop an IM or drop an email into marketing@risual.com, and we'll get back to you as soon as possible. In terms of any requirements or any other guidance that you may need, please don't hesitate to contact myself, which would be callumh@risual.com. Martin's just dropping that into the IM box now. And so feel free to give me an email and I'll contact you as soon as possible for that requirement. So any questions from anyone?
Well, if there's any questions around Lync, and I think one thing definitely with Lync 2013 is the next version of Lync, so Skype for Business. So I think in terms of Skype for Business and load balancing, it's not everything is fully confirmed for Skype for Business, but I believe, Gordon, that KEMP will be a qualified load balancing solution. Gordon, Maurice, you there?
It was on mute. Can you repeat that?
Yeah, so in terms of the next version of Lync, obviously the Microsoft are looking at Skype for Business. So in terms of qualification for load balancing for Skype for Business, it would be believed at the moment that KEMP would be qualified for that.
Yeah, we've got 2 Microsoft MVPs that on our staff that essentially that's their job, is to make sure that they are in place day one with any of the Microsoft releases. So when Skype for Business arrives, day one we will be there.
Cool. Great. So there's one question in IM from Roy. So Roy's asking about how much of this can be virtualized. Is there any latency issues with virtualization?
From the KEMP load balancer point of view, the load balancers can be virtualized even if you're doing a HA pair deployment, and it's all about resource. If you put the resource in there to support the throughputs, and we've got guidelines as to how much virtual resource is required in terms of CPU cores and memory for different throughput levels, then there's no impact there at all. And as Gordon had mentioned, there is no latency introduced by the load balancer in that when properly resourced in a virtual environment.
Cool. Yeah, and I know particularly very useful to use the trials that are available from KEMP's website that you can spin up a virtual load master, whether it's on Hyper-V or VMware, and you can try that today. I think their 90-day trials are the Gordon and Maurice.
30-day trials, but as Maurice has alluded to this morning, we announced a free load master with limited resources, but that would be a really good place to start.
Yeah, Yeah, so that's good. So in terms of virtualization for Lync, from a Lync perspective, Lync 2013 is supported on virtualization. It's supported on Hyper-V 2012. It is supported on Hyper-V 2008 R2. And again, what Gordon alluded to, that resourcing of that virtual environment is critical, particularly with voice and with Lync. Don't use dynamic memory where possible. Don't share resources. Give it dedicated network interfaces if you can, so you can ensure that performance is there. But yeah, it's fully supported on a virtualized environment as well. So you can look at using Lync within virtualization, KEMP from a load balancing perspective, virtualization as well. So you're all covered on that. Has anybody else got any other questions around KEMP, load balancing, Lync? We'll stay on the call for a little bit longer if anyone's got any questions or feels free anything from IM, and I hope, Roy, that's answered your question. Yeah, no problem.
Thank you very much. So just to give you a little bit of background just at the end, guys, we're just we're a KEMP Centre partner, so we're one of 4 in the UK. So anything you need from a risual perspective or a KEMP perspective, please don't hesitate to contact again.
For that as well, if you have any questions, if you want to go through the guides at risual, feel free to give us a shout. I'm happy to help.
Cool. I think from a deployment perspective with KEMP, definitely in terms of the user interface, deployment, administration, everything is very, very easy, intuitive to use. I think that's a great feature on the KEMP load balancer. In terms of setting up load balancing, disabling servers, draining them, it's very easy to use. And I think compared to other load balancers out there, I think that's a key advantage to the KEMPs, and also with the reverse proxy element as well. So there's a lot of stuff you can do with the KEMP load balancers. Thanks, Chris.
Thanks, Chris.
Thanks very much, all. That's very good. That's nice to have an overview.
Yeah. Cheers, Chris.
Cheers for now. Bye-bye.
Thanks, Mike.
Bye.
Cool. So I think that's it. Yeah. We'll end it there. Thanks, everybody.